Hi, it's CNT125. We are now working on our subnetting labs. The subnetting labs we're going to do in three parts. This first one we're going to do subnet planning. The second one we're going to do some subnetting problems where we get the actual IP addresses we're going to use. And then the third one we're going to do where we actually take those usable IPs and apply them to our routers and switches in a network. Okay, so in this first one, what we're really looking at is how to manipulate things like your subnet mask and start figuring out how many subnets you get when you borrow bits, or how many usable hosts you have when you borrow bits. This lab has two parts to it, the front and the back. If I look at the front, I have some information given, and I'm trying to figure the rest out, or I'm trying to, as I like to say, when you're the new IT guy in a crew, what's going on? The second part of the lab on the back is more like when you're the IT admin and you need certain things, what you're going to do to your subnet. What kind of subnets are you going to do, if you will. Okay, so I'm going to get you started. I'll do the first one or two with you here. You'll be able to do the rest on your own, and then I'm going to do the first one or two on the back. Just so you have this as a how to get started, and or if you come back later, you can review this and understand what we were doing. Alright, so this, I'm going to try to do this all digital here. That way it's a lot cleaner than watching my scribble, if you will. So the first part here, I have an example up top. We're given a existing network IP, 195.60.123.23. So when you look at that and the subnet mask, we're trying to figure out what's going on. What is happening, what is going on. So I'm going to ask you to fill in these empty columns here. First thing we always want to identify is what class of network we're working with. As I see at 195, we're dealing with a class C. So my brain should automatically be thinking Class C things. My brain should be thinking a Class C network, default subnet mask of 255.255.255.0, or, network, host octets, if you will. That's what my brain should be thinking. Well, in this case, we have a network where we have a /28-bit count. Okay, if I have a /28, that's telling me I have 28 network bits in my subnet mask. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. That is my subnet mask. That is what we currently have. That's what the /28 means. There's 28 ones in my subnet mask. So with that, if I convert it to decimal, I now have, okay, first octet is 255. Second octet over here is 255. Third octet here is 255. Last octet, I would need to convert that, or as I get more practice, I'll recognize that that is 240. Okay, so this is where the binary conversions that we learned in 120 are coming in handy now. So now I recognize that my subnet mask is 255.255.255.240. Hence why I have that filled in for you. Okay. Well, with that, I'm now asking you how many bits did they borrow. So as I look at that, I see my normal should have been 255.255.255.0. So these bits right here, these ones right here were the borrowed bits. I see 4 ones are being borrowed. That's where that's coming from. So with 4 bits borrowed, if you remember our shortcut, if I look at my borrowed bits, if I look at my place values for binary, 2 to the 4, and I have them on the next page down here for you, 2 to the 4, here's my 2 to the 4, right there it is. My 2 to the 4 tells me there's 16 subnets being created. So with this, 2 to the 4, I'm getting 16 subnets. Well, how many bits are left for hosts? Well, taking a look here again, I borrowed 4 bits for subnet. There they are. How many bits are left for host? There's the 4 bits left for host. So if there's 4 bits left for host, again, 2 to the 4 down here, down on this page, 2 to the 4, tells me that there's 16 hosts or addresses per subnet. So here is the 16 addresses per subnet. That's what we're getting here. And that tells me if I subtract the 2 for the network number of the broadcast address, I'm left with 14 usable hosts per subnet. 14 usable address per subnet, if you will. So there's my sample up top. We're going to duplicate that on the ones below. So let's do the next one down here. 210 tells me that this is a Class C. So I'll put Class C here. That's a Class C network. Again, I should be thinking default. Up here is my default 255.255.255.0 network host octets. We're given a /30. So let's figure out what the /30 is. Again, until you get handy with this, here's my 888. There's my 24 bits. 25, 26, 27, 28, 29, 30. There is my subnet mask with the /30. 8 is 16, 8 more is 24, 25, 26, 27, 28, 29, 30. So now I convert that to decimal to get my decimal subnet mask. So this guy here, I can either add all these up and figure out what it is, or I can subtract these two place values. These two place values are the 1 and the 2 place. So 255 minus 3 gives me 252. Again, the more leaning back on your conversions you learned in CNT120. There we go. So 252. There is my subnet mask, 255.255.255.252. So if I look at my borrowed bits now, these are my borrowed bits. We got 6 bits borrowed with 2 bits left. So we have 6 bits borrowed this time. So there's my 6 bits borrowed, and there's going to be 2 bits left. I'll just put that over here to remind me, 2 bits left. So with 6 bits borrowed, look at my conversion down here, or look at my place values, excuse me. Look at my place values. 6 bits borrowed, I'm getting 64 subnets. Okay? So up here I have 64 subnets. 2 to the 6 is going to give me 2x to the 6 is going to give me 64 subnets. And if I have 2 bits left, 2 to the 2 is going to give me 2 times 2 is 4 hosts per subnet. Of which, how many are going to be usable? We're going to end up with 2 usable. That's it. So again, down here, I'm left with 2 bits. 2 bits, I get 4 addresses minus my 2 for the network number and the broadcast address, and we're left with 2 usable hosts per subnet. That's what I'm going to do on the front over here. And just be aware as you get to B's and A's down here, you're going to do the exact same thing. You're just going to have more octets to worry about. Okay? So if I go down here to one of these, let's pick on, if I look at my 131, 131 is a class B. Okay? With this guy, class B, we'll do this guy, /20. Okay, well, let's come down here. If I'm dealing with a class B, I should be expecting normal stuff of 255.255.0.0 or network host, or excuse me, network host, there we go. And I should be expecting, okay, well, let's take a look. I should say I should be expecting 1, 2, 3, 4, 5, 6, 7, 8. I erased too much. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I should be expecting this 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is my normal class B stuff. Well, in this case, we're dealing with a /20. So I need to figure out what the /20 is. So there's 16, 17, 18, 19, 20. There's my 16, 17, 18, 19, 20. And I now have, if I take a look, there's my 4 bits borrowed, and I now have 8, 9, 10, 11, 12 bits left. Okay, so I would now convert this over to decimal, 255 dot, this guy here, dot 240.0. So now I have 255.255.240.0. So slide that over, 255.255.240.0. And that told me that I borrowed 4 bits. With 4 bits borrowed, look at your place values down here. 4 bits borrowed, I have 16 subnets. So this guy, 4 bits borrowed, I'm going to get 16 subnets. Yahoo! Better slide that over so it's a little easier to see. And on this over here, how many bits are left? We'll take a look. We borrowed 4. I am now left with these 4 plus these 8. I have 12 bits left. So I'm going to have 12 bits left. 12 bits left is going to give me, take a look, 2 to the 12, way over here, 4096 addresses per subnet. So, actually, let's edit this guy. 4096 addresses per subnet, of which, if I take a look over here, 4094. There's the subtract 2 for the network number and the broadcast address. That's what you're doing on the front half. Do the other C's, the other B's, and the other A's down here for this guy, just using the same method I was using here. Okay? I'm going to pause a second while I save my files, and I will come back in 2 seconds for the back half. Okay, if I look at the back half now, we're doing the same thing, but we're just going to go in reverse order. So I had a sample up here. Okay, we're going to go in reverse order now. So we're now going to say, what do we need for subnet mask to accommodate this stuff over here? So we're dealing with 220. This is a class C. All right. And we need 16 subnets. So to get 16 subnets, over here, 16 subnets, we're going to borrow 4 bits. 2 to the 4 gives me 16 subnets. So we're going to need to borrow 4 bits to accommodate this. So if I have a class C, and here's my class C stuff up here, here's my class C. If I borrow 4 bits, well, let's just edit this because I had this from before. I'm going to need to do that. If I borrow 4 bits, I'm left with 4 bits left for hosts. So let's finish that, and then we'll come back to alter our subnet mask. So 4 bits borrowed is going to give me 16 subnets. I'm going to be left with 2 to the 4, and that'll give me 16 addresses per subnet, of which 14 will be usable. So to accommodate what their need is, they need a 16 subnets for some reason. If we borrow 4 bits, that'll give us those subnets, and it'll give us 14 addresses per subnet. Well, to do that, I now need to alter my subnet mask to reflect that, so my routers and switches know what I'm doing. Well, I just did it right here. This was the borrowing 4 bits, so I'm going to end up with .240 and a bit count of 88824, 25, 26, 27, 28. So I'll have a bit count of /28, and my subnet mask will be 255, 255, 255, 240. And that will accommodate this number of subnets they need. That's all we're doing in the back. We're doing the same thing. We're just starting on this side and working backwards. If I come down here, let's do a bigger one with one of these. Okay. If I do this guy down here, 128, that should be a class. Pause for a second, let you think. That's our class B. Okay. So with a class B, we're now looking at this information. This is my norm, if you will. And we need to, well, we need 1,000 hosts per subnet. So in other words, we need to make sure after we borrow bits that we have at least 10 bits left. We have at least 10 bits left. So in this case, instead of looking at the number of bits we're borrowing here, we're just approaching it backwards, saying we need to make sure we have 10 bits left. So 8, 9, 10, I can borrow up to this many right here. Okay, so let me delete this out. We'll convert that in a second. So we have 8, 9, 10. I need to leave 10 bits behind. We can borrow up to 6 over here. So with 6 bits borrowed, that would accommodate their need, or leaving, as we said, leaving 10 bits behind. So here, if I leave 10 bits to the 10, that's going to give me my 1,024 addresses per subnet, of which 1,022 are usable. We'll have enough host addresses. And to do that, I can borrow up to 6 bits. 6 bits is going to give me, as I see, 6 bits, 64 subnets. We'll get 64 subnets. That's going to work. And when I do that, if I write out all of my conversion here, 255, 255, 252.0, this is going to accommodate their need. So this guy here, 255, 255, 252.0, will do that. And my bit count is going to be, as I take a look, 88, not quite, 8, 8, 16, 17, 18, 19, 20, 21, 22. We'll have a bit count of /22. Okay? So that's all we're doing in the back half. We're just kind of approaching it for the back end and making sure we're accommodating either enough bits for hosts or enough bits for subnet. And then we alter our subnet mask and bit counts over here. That's all we're doing in the back. So there's your subnet planning lab.